The last video looked at classifying matter as a pure substance or a mixture. The pure substance could be broken down into two categories. Those two categories were the element and the compound. And the key to the pure substance being that all particles are the same. In an element, all particles are the same because they're all the exact same atom. A compound, all particles are the same. They're the same chemical structure, but it might just mean that you have more than one type of atom bonded together, chemically bonded together, forming a substance with new properties and a very specific ratio. But as long as every molecule was the same compound, it was still considered pure. Mixtures are a little different. We kind of said in a mixture you have a physical combination of different substances. In a physical combination, everything keeps the same properties, different than a compound, which was a chemical combination where the properties change. The mixture can be classified into one of two categories, homogeneous and heterogeneous. The prefix homo means the same. Hetero means different. Hetero, different. This kind of refers to like how the mixture appears to you. In a homogeneous mixture, all of the substances are very evenly distributed throughout. I usually say like it looks the same. It looks the same throughout. A good example might be something like salt water. Salt water is just a mixture. It's a physical combination of salt and water. It's physical because I can still like reverse it. With just a physical change, all I have to do is evaporate the water, which is a physical change. I can condense the water vapor and boom, now I have pure water with the exact same properties it would have originally had. Left in the bottom of my container would be solid salt with, again, the exact same properties. If you go boil some salt water from the ocean, you're going to get this crusty solid left over. It's a physical combination, but it looks the same throughout. The salt and the water are very evenly distributed. You don't see chunks of salt and, oh, here's a pocket of water. I mean, it's very evenly mixed. Other examples, things that might come up, I don't know, like throughout the year. An alloy. An alloy is a mixture of metals. For example, brass. Brass is a mixture of copper and zinc. But if you look at something that's made of brass, it looks like everything is very uniform. Again, you don't see like, oh, here's some copper, here's some zinc. It's perfectly mixed, very evenly distributed. In a heterogeneous mixture, I like to think that it's going to look different, that you're going to notice the different substances. Looks different throughout. Okay, so it says here, particles of the different substances are not as evenly distributed. Example. I don't know, maybe this is like dirty water, like muddy water. Or like you can see the mud, you know, maybe after a while it kind of even settles down to the bottom. It's not a very even distribution of particles throughout the mixture. And people will always use the example of like a salad or cereal or something like that, where it's very noticeable that there are different particles in this mixture. And again, in both mixtures, even in homogeneous, everything keeps the same properties. Even in brass, alloys are made because you want like a combination of properties. So maybe you want like the color of the copper, but you want to make it stronger by adding zinc. It's like you'll get this alloy that really has kind of like a mixture of the properties of the individual metals. So even though it kind of looks more evenly distributed, the substances still keep their individual properties. Heterogeneous really just means that it's going to look more different throughout. You'll notice that the substances are not as evenly distributed. But there are both different forms of mixtures. They're both physical combinations.